The divisions on the main scale, okay, you can see on the screen, they are same like the normal scale. That is, there are 10 divisions here in centimeter, that is 10 centimeters, but normally it will be up to 15 centimeters. And every centimeter again divided into 10 part, that is there are 10 millimeter divisions inside the centimeter. Now these divisions are called main scale divisions. They are also indicated by MST. Now the second scale, that is the Vernier scale, okay, which is sliding over the main scale, that is called the Vernier scale. And you can see that there are 10 parts on the Vernier scale, and these Vernier scale divisions, they are also indicated by using VST. And this scale, okay, it can slide over the main scale. You can see it on the screen. Okay. Now, if we see the next part, the first part is the main scale, the second part is the Vernier scale, and the third part is the external jaws. Okay, the jaws that you see at the lower part of the main scale, that is J1, J2, these are the external jaws. Okay, the external jaws are used to take the measurement of the external dimensions. For example, if you are having a ring, and if you want to measure the outer diameter of the ring, then the ring is inserted between the two jaws J1 and J2 as shown in the figure, such that the two jaws are touching exactly the outer ring, the outer circle of the ring. Now we go for the internal jaws, that is the fourth part. Okay, they are denoted by using J3, J4. These internal jaws are used for measuring internal dimension. That is the reason the name is given as internal jaws. To understand like how these jaws are used, okay, you take a cylinder or cylindrical object which is having some thickness. Okay, so now to measure the outer diameter, that means we need to take the diameter of the outer part. Okay, that is denoted by D out, that is the diameter of the outer part. Or simply you can, if you just look at the one side of the cylinder, okay, the diameter of the outer circle, okay, that is the outer diameter. Now you can see one more circle inside the outer circle, and the diameter of that circle is, the inner circle is the inner diameter, that is denoted by D in. Now to find out the outer diameter, we need to place the cylinder in between the just J1 and J2 as shown in the figure. The reading on the Vernier calipers gives the diameter of the outer diameter of the cylinder. Now to find the inner diameter, we need to reverse the cylinder and insert in such a way that the two jaws, that is J3 and J4, are the inner jaws, should touch the inner circle exactly on the opposite sides. Okay, the reading on the Vernier calipers gives the diameter of the inner circle or the inner diameter of the pipe. Okay, now there is one more part, okay, which is also as important as the two jaws, that is internal and external jaws, that is the tail. Okay, this part is used to measure, okay, the depth of the hollow parts which are inside the given objects. For example, if you wanted to find the depth of the cylindrical structure or a tube, okay, we cannot place these two jaws inside the hollow part. In that case, we use the tail. The tail moves along with the Vernier calipers. Whatever the distance it covers on the main scale, the same distance will be covered by the tip of the tail. Okay, therefore, the reading on the Vernier calipers gives, okay, the depth of the hollow part of the cylindrical structure or the tube. Okay, to understand this one, okay, for example, if you are having a tube or cylindrical structure which is having some kind of hole up to certain distance, not from the top to bottom. So in that case, if you wanted to find the outer length, okay, what is the total length of the given pipe or cylindrical structure? So in that case, we measure the length by using the two jaws. Okay, that is external jaws J1 and J2. But if you wanted to find what is the depth of or what is the length of the hole inside the cylindrical structure, okay, we need to insert the cylindrical structure something like this. And here, okay, the top or one side of the cylindrical structure should be in touch with the main scale. and the bottom or the tip of the tail should touch the bottom of the hole. Okay, so the reading on the vernier calipers in this case gives the depth of the hole inside the cylindrical structure or the hollow part of the cylinder. Okay, the next one, the principle of the vernier calipers. Okay, now till now we have seen the different parts and how they are used and for what purpose they are used. Now the main part, okay, that is the idea based on which we use the vernier calipers. Okay, that is the principle of the vernier calipers. And this part is like the heart of the topic vernier calipers. So here we need to understand like how we measure. So in case of a normal scale, I said like, okay, it has like each centimeter is divided into 10 parts and therefore each part is of 1 millimeter. So but in the case of vernier calipers, I said like, okay, every millimeter on the main scale can be divided into 10 parts, that is 0.1 mm. Now if you look at the magnified figure of the vernier calipers, okay, you can see, okay, there are some 10 divisions on the vernier calipers and the entire like length of the 10 divisions is coinciding with the few divisions on the main scale. Okay, so now we take the line diagram of this part to understand more clearly. We take the magnified picture of this part